Topic here. We're going to get away. We're still going to talk about triangles, but we're going to talk about any type of polygon in general and when are they congruent to each other, because that's the big topic for this unit is congruent figures. Right up here, I have ABCD and I have another quadrilateral that's WXYZ. And everyone see what I gave you here? Read the givens here. What do I know about those two quadrilaterals? What do I know about those two? Let's start there first. What's given about those two if I just read the givens? Jonathan? They're equal, they're congruent to each other. So today, what does that mean? Right? What does that mean that they're congruent to each other? Here's what it means. What I want you to do right now is visually put ABCD right on top of WXYZ. Smack it right on top of it right now visually. All right? Can everyone see that? Move it. You're just not going to slide it over, right? You got to flip it and then slide it over and put it right on top. What it means is when they're congruent to each other, those sides that are matching up are congruent, and those angles that are matching up are congruent. That's what that means when two figures are congruent. If I put them right on top of each other, all the angles that match up and all the sides that match up are congruent to each other. So I'm going to first start with somebody. Name a pair of sides that match up in each of those figures. If you put them right on top of each other, name a pair of sides that would match up. Let's start there. Name a pair of sides that would match up in each of the figures. Madison. CB, I like it. Yep. So CB and XW would would match up. Agreed? And because I know those figures are congruent, so are those sides that Madison just gave us. The ones that matched up with each other. CB and XW. All right, there's more. Let's go. Give me another pair of sides that would match up. Give me another pair of sides. Ran? AB and YZ? AD, thank you. You got. I like that. AD and YZ would definitely match up, and they would be congruent because the figures are congruent. All right, let's keep going. We got two more pair up here. Give me another pair of sides. Another pair of sides that match up. Keating?
AB and WZ.
Yep, I like that pair. AB congruent to WZ. Nice work. And there's a fourth pair up here that would match up. And how about that fourth pair that I need up there? Fourth pair, Mia?
CD.
Yep, works for me. CD is congruent to XY. Good. So do the angles, though. The sides match up, and so do the angles, and they would be congruent to each other. So now give me angles that match up. Just give me a single letter to make it easy on us, all right? Give me a pair of angles that would match up if you put those two figures right on top of each other. Taylor?
Angle A is congruent to angle W.
Whoa, A and W?
Oh, wait, A and Z.
There you go. There you go. Good. Good fix. A and Z would match up since the figures are congruent. So are the angles. Let's keep rolling. Another pair that would match up. Jayla? Yep. Perfect. D would be congruent to Y now. Another pair. Alex? I already have that. B congruent to W, good. And process of elimination, I'm not going to ask anybody. Angle C is going to be congruent to angle X. All right, couple things now. Couple things before I move on. I kept saying the sides that match up, the angles that match up. I want to give that a term now, all right? Because I don't want to keep saying, hey, it's the sides that match up, all the angles that match up. These here, all of these are called corresponding parts, okay? Parts. I don't call them corresponding sides or corresponding parts, all right? The parts that match up to each other. The sides and angles that match up, corresponding parts. And I have an admission to make right now. As all of you were telling me the sides and the angles that matched up, I didn't even look at the diagram to know if you were right or wrong. I didn't even look at the diagram. I knew right away. And it's not because I've been doing this for thousands of years. You want to know my secret? I did not look at the diagram. You want to know what I looked at? That statement right there. That statement is written in a particular order. What do I mean? Look where CB is in that statement. See how it's the second and the third letter? Everyone see that? Look over here in the other quadrilateral. What's the second and the third letter? XW. Take a look. Angle A and Z. Look where A is in the statement. It's the first letter, isn't it? And then it matches up with the first letter in the other statement, which is Z. That's how those statements will be written going forward. They will match up the corresponding parts for you already. All right, so I don't need a diagram. Everyone see? So like the first and the fourth letter match up with the first and the fourth letter in the other diagram. Okay, always. That's how it is. Those will be written in a specific order every single time. Questions there? So when two figures are congruent, so are their corresponding parts. And you can always look at the statement to see what parts match up. All good? I ran out of tissues, so I'm sorry if anybody needs them because tears are about to come. Okay, I'm sorry. All right, I'm sorry. Here we go. We're back at it. We are back at it right now. All right, statements, reasons. I told you this was a heavy proof unit. You had 2 days off. Not anymore, though. Not anymore. I know there's a theorem box up there. We'll fill that in a second. We'll fill that in at the bottom. Decide whether these triangles are congruent. How are we going to know if they're congruent or not? If listen to me, all the corresponding parts need to be congruent. So all the sides that match up have to be equal, and all the angles that match up have to be equal. All right, that's when two triangles will be congruent today, if all their corresponding parts. So that's what we need to prove. Are all the corresponding parts congruent? So I'm going to take this nice and slow. Put your hands up if you have questions or concerns. All right, because it's not getting any easier. So that's our goal. Prove to me all the sides that match up are congruent, all the angles that match up are congruent. And yes, we're going to be using stuff from Unit 2. All right, let's see here. B and D are right angles. Hopefully we can put the symbols there, right? B and D, right angles. We have some line segments that are congruent. AB, congruent to ED. We'll double up here. BC is congruent to CD, double up, and then looks like we're going to have to triple up. AC is congruent to CE. And remember, the triangles won't be congruent unless all the angles and all the sides are equal. What is already taken care of? I gave you a lot of information. What is already taken care of as far as the corresponding parts go? What do you already know are congruent up here? Where are we going on this one? Keating again?
All the sides are equal.
All the sides are done. They're done, guys. All the sides are done. We don't have to pay attention to those. What we need is, how are all three angles equal to each other now? All three pairs of angles. Do you know any angles that are congruent automatically up here? Do we know any pairs of angles that are automatically congruent up here? Because the sides are done. I'm done with the sides, right? We're done. We were given that they're all congruent. How about any angles up here congruent that you can see? Any angles that I can write down are congruent. Keating, back to you.
B and D.
Yeah, why? Because they're what?
Right angle.
There you go. So angle B is congruent to angle D. And this is not new. I'm not teaching you anything new here. Why are B and D congruent? How does Keating know that? Why are B and D congruent? T? All right angles are congruent.
Don't you have to state it's right angle first?
Say that again, Taylor. You're correct. Say that
Don't
again.
you have to state that B's a right angle first?
Don't we have to say where the right angles are? We do, but it was given already. You are correct. If that wasn't given, I do need to state where they are, and that'll happen coming up here soon. But you see how it was given already. Good point. All right angles are congruent. Perfect. All right, one pair of angles down. We got two more to go. We got to show all three pair are equal. Oh boy, this is going to be brutal here. Come on. Look at the diagram. Any other pair of angles we know are congruent as well? We should. Anybody see another pair of angles up there that should be congruent based on our discussion so far this year? Got it, Taylor?
I think so. AE.
A and E? Is that what you're saying? A, because AE isn't an angle. A and E
A
are.
and E, yeah.
What's your reasoning going to be?
Would it be alternate interior?
What do you need?
No,
They,
no,
whoa.
no.
They are alternate interior, but what do you need for them to be congruent?
Taillights.
Do I have that?
No.
Okay. So,
No, so we can't
good.
use that.
Okay, yep. Good thought. That's the way we should be thinking here. A and E look to be alternate interior, but I don't have parallel lines, so I can't say they're congruent. There's something else in here. Alex?
BCA and BCD.
Woo! Okay, I'm going to write it down. Nothing new. Nothing new. How does Alex know those are congruent? What did we just mark up there? Halo?
Vertical.
Those are vertical. Those are vertical. Guys, this is where we got to be, right? This is where we got to be. We got to notice that those are opposite vertical. They're vertical angles. Vertical angles are congruent. They're congruent. I got 3 pairs of sides. I got 2 pairs of angles. The only thing we need left is what? A congruent to E. That's the only thing we need left to say the triangles are congruent. And that's where I'm going to take over right now, because this is the new piece to today. Angle A is indeed, at this point, congruent to angle E. And this has to come last. You could not have said it in step 2 or 3. This has to come last. And here's why. You don't need to write any of this down here. I'm going to say that's 80, that's 70, that's 80, and that's 70. So 2 pairs of angles are congruent, right? 80 and 70, 80 and 70. How many degrees do I have left? Anybody want to do a quick mental math there? I got 80 and 70, that's 150. So how many do I have left? And how many degrees do I have left in this triangle? So you're telling me if 2 pairs of angles are equal, so are the third pair? That's what you're showing me here, right? If 2 pairs of angles are congruent in a triangle, the third pair must be congruent. Okay, before we write that in our reasons, that's what I want in the theorem box down below. Is this a new theorem here, which says in 2 triangles, if 2 pairs of angles are congruent, how do you think I'll end this? If 2 pairs of angles are congruent, so are the third pair. But good news, you're not going to have to write all that in the reasons column here. I got it. There's an actual name attached to this, and it's called the third angles theorem. Okay, it's called the third angles theorem. So I will allow you to write that in your proof if you need it. So going down here, that is going to be my reason for number 4. I already have 2 pairs of angles congruent, so the third pair must be equal by the third angles theorem. Ooh, we're not done. We're not done yet. Not done yet. What were we asked here? Prove the. What was the ultimate goal here? Prove what? The triangles are congruent. So you need to say the triangles are congruent. So here we go. Last step. Triangle. Name one of the triangles any way you want right now. Name one of the triangles any way you want. Keating again. Keating, go ahead.
Triangle CBA.
Okay, that's fine. Triangle CBA. Notice I told them name it any way you want. Congruent to, you cannot do that for the second triangle. Why? Remember what we just did at the beginning of class. The sides that match up and the angles that match up have to be written in the correct order. All right, so you can't just call the second triangle anything you want. Angle C has to match up with whatever it's congruent with. B has to match up with it it's congruent with. All right, so you need to write this in the correct order so when we look at it, the corresponding sides and angles match up. So see what you can do here. If we go CBA, what's the other triangle's name? Where everything would match up. All right, what do you want to call the second triangle if we call that CBA? Where are we going on this one here? Lennon?
CDE.
CDE. That's the way it's got to be. Correct. Good job. B matches up with D, A matches up with E, and so do the sides. B, A, D, E. And then the reason for today, anyway, it's going to be definition of congruent polygons. That's going to be why the triangles are. If all the corresponding parts are congruent, so are the triangles. All right, one doesn't make you great. Here we go, buckle up for another one. I'll give you time to mark your diagram. Everything's already written in for you. Mark your diagram with whatever you need. And we need to prove those two triangles are congruent. I am missing a marking because I want to see if you're doing it. All right, I purposely didn't put a marking on because I wanted to see if you guys knew what one of the givens was telling you. Okay, so my diagram is not complete. It should have something else on it. Okay, good. My diagram's missing the right angle symbols. I just want to make sure people were putting those on. Now, hey, watch. Just because I'm putting them on my diagram doesn't mean that's in my proof. Okay, so just a heads up there. Just because it's marked on your diagram doesn't mean it's in your proof yet. All right, I'm going to go around the room here. Let's see what we got. I have 2 pairs of sides and 1 angle done. That's it. 2 sides, 1 angle. I need 3 sides and 3 angles, but the only thing I was given was 2 sides and a pair of angles. Where else do you want me to go here? Where else do you want to tell me anything being congruent or what to write next? All right, because all I have is 2 pairs of sides and an angle. I need 3 pairs of sides and 3 angles. And there is no such thing as the third side theorem, by the way. Just because 2 sides are congruent, that doesn't mean the third pair are. That's only for angles. All right, anything you want to tell me here that's true about the diagram? Taylor, want to start anywhere?
Angle and supplementary to
What did we put on the diagram?
like things proving what's congruent.
Right, we had the congruent angles aside. What are these right here that we just put?
Right.
Did we say they were in the proof yet?
No,
Yeah, so we probably want to, that's what I'm saying. Just because it's on your diagram, I still need to know about it in your proof. So angle, name the right angles now, Taylor.
Angle CNG.
Yep.
And GND.
Are right angles. Got to say they are right angles first. Can't say they're congruent yet. How'd you know they were right angles?
Because they're perpendicular.
Perpendicular lines form right angles. Good job there. Once you tell me they're right angles, what should we do at the very next step? Get in this groove now. Very next step. Jesse, if they are right angles, tell me they're congruent. Yeah, because that's going to be my second pair of angles. So CNG is congruent to GND. We just use this one, all right angles congruent. All right, 2 angles down, 2 sides down. Now I need one of each now. I need to get those sides equal and the other pair of angles equal. Everyone's good, right? I need one more pair of sides and one more pair of angles, and you guys know where they are. So talk to me here. Do you want to do the angles or do you want to do the sides that are left? You want to do the angles or the sides here? Juliana, what do you want to do? Angles or sides?
Angles.
Angles, yeah. What do we already know? C is congruent to D, and we just proved another pair. So why does the remaining pair have to be equal then? Right?
Yeah.
Everyone, yes? If I got 2 pair congruent, the third pair automatically has to be congruent by third angle theorem. There it is. And what's that pair, Juliana? Angle. What's the pair I haven't said we're congruent? I got C congruent to D, and I got the 2 right angles. Where are the other 2 angles in each triangle that need to be congruent? Let me cover up. Where's the other angle we haven't talked about in that first triangle?
G.
Oh, be a little more specific, right? CGN. All right, so CGN has to be congruent to. Now go to the other triangle. That would match up with what angle? These 2? Yeah, here you go. You have these. You see what? I should probably go back. Do you see the 2 triangles we're trying to prove congruent? These 2, right?
Yeah.
That one and the one next to it here, right? Okay, so I already have these 2. I already have the right angles. You see the third pair that I don't have marked yet? CNG right here is going to be congruent to what would it match up with if I put them on top of each other? This angle and see how they would match up? Yes, no?
Yeah.
Everybody else, we good? How those angles are the third pair in each triangle? Because I have this pair, I have this pair, and now I need the third pair. So how do I name that angle now? Finish that off.
G.
I'm looking for this angle right here, this name of that angle.
GND.
That's the right angle. Remember, 3 letters, that's got to be the vertex of it. That's got to be in the middle. N, G, N, or D, G, N, or N, G, D. Okay, good. Angle N, G, D. And what did we say the reason's going to be?
The
Third angles theorem. So I have all 3 pairs of angles. Oh, we're missing 1 pair of sides. All right, we're missing 1 pair of sides. I'll talk you through this one now. Where am I going with this one? Jayla, do you see where the sides are? The third pair of sides I don't have equal. Let's go to the triangle on the left. What's the only side I haven't talked about? Well, what do you have? GN, okay, yep. And what about the triangle on the right? What's the only one I haven't talked about? GN? That's the only side. What do you know about GN and GN? They have to be equal to each other, don't they? Because we're going way back here, but reflexive. Yes, reflexive. So GN is congruent to itself, and that's a shared side. They both have a side that they share, and that's reflexive. All right, do I have all pairs now? 3 pairs of sides and 3 pairs of angles. Do we have them all? I believe so. So now we can say the triangles are congruent. You guys started off. Name one of the triangles. Actually, never mind. I'm not even going to bother asking. It's already up there. We can just copy the proof statement. CNG congruent to DNG. Ask any questions on how any of these angles or sides came to be. And then the only thing else I want to do with you is I want to make sure you guys can match up Write a congruent statement for me now. A congruent statement, which is this triangle congruent to this one in the correct order. All right. Oh, sorry, we didn't go. I didn't write the reason, right? What is the reason? Definition of congruent polygons. Thank you, Mia. We'll change the reason on Monday, but for now, that's what it. Once you have all 6 pairs equal, definition of congruent polygons. All right, final one here. Write a congruent statement. Triangle so-and-so congruent to triangle so-and-so here. How do I know? Wait a sec. Wait. Maybe you can guys. I'm having an issue here. I see all 3 pairs of sides are equal, and I see 2 pairs of angles are equal. I don't think these triangles are congruent, are they? Because I only have 2 pairs of angles marked, and I've been told today I need all 3 pairs equal. Do I even need to mark the 3rd pair? No, why not? I already know they're equal by what? 3rd angle theorem. Okay, so that's why H and R are not marked. They're already congruent by the 3rd angle theorem. All right, name the first triangle any way you want so we can match it up. Name the first triangle any way you want. Alex, triangle. We just name it by its vertices.
DHF.
DHF. So if I go DHF, the second triangle has to be written in a certain order. Okay, you can't name the second triangle any way you want. So go ahead, take a minute and match them up. If we go DHF, what do we got to go over here? All right, what do we got to go on the second triangle? Let's finish this off here. Madison, what's the second triangle got to be named? Z, what was the second letter? Z, P. What's H match up with? R, so R has to come next because H is in the second spot. So whatever it matches up with, R has to be on the second spot, followed by P. Okay, their sides and angles have to match up. All right, let's get going.